Hello, ladies and gentlemen. I hope you had a great start yesterday. Hello? Is it on? Okay. Today I want to talk about sapphire. We just heard silicon is the solution, but we think it's maybe only one part of the cake. There's also other part, and we want to talk about how we can do this more green, more sustainable, and also more geographically better. Let me allow maybe a few words to our company. We are from the Ebner Group. Ebner is a hidden champion for furnace technology for 75 years, very traditional company, but back then also with the semiconductor boom, they were like, we need to also go into semiconductors. And since 2005, we focus on crystal growth, first for polysilicon, also now for silicon carbide. We are currently in 200 millimeter silicon carbide process qualification. But also today, we want to talk about sapphire. Since 2013, we're doing the sapphire furnace technologies. First the tool as such, then the growth, and especially since 2021, the 200 millimeter sapphire growth and qualification. Maybe a few words for the supply chain. If you think sapphire wafers, where they're coming from, usually they only come from, let's say, China, to be honest. Most of the sapphire, 95% of it's produced in China. If you look somewhere else, there are a few other companies that do that as well, but you can count it on one hand. So for us, it was clear, okay, we need a solution for European customers, but also for maybe US customers to have a differentiated supply chain. For that, in Austria, we have our R&D. It's still on 150 and 200 millimeter sapphire, but also we have our daughter company, Arctic Sapphire, and it's sitting in Norway, right next to 3 hydroelectric power plants, so we are able to produce with 100% green energy, which is very important for us. Furthermore, we have a joint venture or collaboration with an Australian company. They produce the aluminum oxide, which is then necessary to produce the sapphire in a more clean, environmental-free environmental process. Also, they have our furnace tools. They have now the first 2 furnaces ready there, and also produce the sapphire there. So if we have supply for 200 millimeter or 150 millimeter sapphire, it's coming out of 2 regions. So it's already quite diversified. Furthermore, we are in talks, of course, with the sapphire growth. It's one part, but you need to have the wafer. And wafering is not so easy on sapphire. It's mostly done on 4 inches still. There's very few for 150 and even less so for 200 millimeter. And you were talking about maybe 300 in the future. I think 300 millimeter is going to be even more difficult. I think from the growth side we could do that, but for 200 millimeter there's only 1 or 2 companies that can do that. And we work with them very closely, and our long-term commitment is to establish another fab, wafering fab outside of China there in the new term. Yeah. Maybe a few words about sapphire growth methods. It's mostly Kyropoulos. That's used in China, back then also in Russia, but it's defunct now. There are other methods like Vernu, which is used for watch glass making, edge-defined films for larger windows, but we use the AGM. It's a modified AGM, since the normal AGM can only grow on A-axis, but for normal wafers you need C-axis, and we modified it heavily, had 10 years of R&D on it, and are now able to produce since a few years on C-axis. Yeah. And with that, I would like to hand over to my colleague Gourav, and he can give you a little bit more insights about the crystal growth technology.
Thank you, Markus. So I would like to take a bit through the technology that we have developed. So we have invested about 10 years in developing a technology such that it caters exactly to the LED market to provide LED substrates, and we have optimized it for 8-inch LED substrates. So what you see here is, so this is a molybdenum crucible. So we grow the sapphire crystal in such crucibles. So we start by placing a sapphire seed at the bottom. So this seed is cut from a previous sapphire crystal, and it has all the crystal information. So this is oriented along the C-axis in our case, because we want to grow C-axis crystals. Then we charge it with aluminum oxide in the form of aluminum oxide powder or sintered material. So